Hello. Thanks very much for inviting me to participate in this presentation of my paper on deterioration of cane quality and milling performance in the industry from 2007 to 2016. The background to this paper is that prior to 2000, growers were paid pro rata of their share of industry proceeds based on the sucrose content of their cane. Post 2000, growers were paid their share of industry proceeds pro rata based on the total recoverable value that a miller could extract from their cane. And this change was designed to incentivize both millers and growers to be more cognizant of the quality of the cane. The current cane payment system, growers receive 64% of the value of the sugar and of the molasses sales in the country. And domestic sales are valued at the national price, and export sales are valued at export prices. This value is then distributed between growers in proportion to the value that is recoverable from their cane, the RV from their cane. The recoverable value comes in two components, the sugar value, and the sugar value is estimated using Van Hengel's ERC formula from 1974 at the ISCCT. The ERC formula, you can see there, has A times S, A being the recovery of sucrose in the sugar, less B times N, B being the loss of sugar to molasses, which is in proportional to the N, non-sucrose content of the cane, and a further loss, C times F, of the loss in sugar to the fiber content in the cane, which is apparent in the loss to bagasse. The molasses value is determined by the factor M times the non-sucrose content of the cane. And then that quantum of molasses is multiplied by the molasses price. The RV formula actually looks a little bit similar to the ERC formula, but you'll see this A is absent. In fact, it's not absent, it's there, but its value is 1. The B is replaced by D. Otherwise, the formula looks very similar to the ERC formula. Now, in this formula, of course, the S is the sucrose percent cane. I said to you that A is 1, sits in front of the S. The D is the factor that reduces the amount of sugar that would be made, or the value of the sugar that would be made, because of losses to molasses, but it also adds back the value of the molasses that's made, proportional to the amount of non-sucrose delivered to the mill in the cane. The C is a factor that reduces the amount of sugar that will be made due to the losses in bagasse, and that's per unit of F, which is the fiber percent cane. Now, with this formula, and it has the units of tons of sugar, RV has the units of tons of sugar per ton of cane, or tons of sugar per 100 tons of cane, if you're talking about RV percent cane. Now, growers became aware of the changes in the D component of this formula because every month as the growers get notified of the new RV price, so they're also notified of the current D value. And it was possible to see that with time, the D value was getting bigger, therefore the losses were getting bigger, and growers then wondered, wow, what's happening to the other factors in this formula? And that all prompted this series of work. Now, this is a bar cluster that shows the sugar made at each mill in each year and it's expressed as a percentage of the sugar made in the 7/8 season. So the left-hand bar in all of the mill areas will be 100. That's where it was made, with the analysis started. I take the example of Felixton, which is the leftmost cluster, and Amatikulu, which is adjacent to that. And you can see that from this 7/8 season, Felixton made more sugar per unit of the sugar in the cane for a number of seasons, and then, of course, it started to fall off. Amatikulu, adjacent to that, showed even more dramatic fall off in the amount of sugar that was being made from the sugar content of the cane that was being delivered. Go across more towards the right of this cluster of graphs and see there's Komati. The Komati's production has been pretty consistent over the period of time. Right on the right-hand side of this graph is the industry average. And you can see that from the 7/8 season on, the average industry production of sugar per unit of RV in the cane has deteriorated. Now, in order to analyze this data, first of all, the data was obtained from the CTS service at the Sugar Association. And I did simple linear regression on all of the factors, A, and B, and C, which are the mill-related factors, sucrose, non-sucrose, and fiber, are the cane-related factors. And I say here, actually, I didn't regress A, because A, I said, is the recovery of sucrose in the sugar. But I'm actually looking for the losses. So 1 minus A must be the non-recovery, the loss. Now, a further factor that I determined in this data was what I've termed the sum of the losses. And the sum of the losses is, in that formula is shown there, so it's 1 minus A times the sucrose. That essentially is the amount of sugar that was lost to undetermined losses in the mill. Added to that is the B times N, which is the sugar lost to molasses in the mill. And added to that is C times F, which is the sugar lost to the fiber in the mill. When I did those regressions, I'm not really interested in what the actual numbers are, but I am interested in how those numbers are changing with time. So I was able to determine the rate of change, which is if you do a regression, simple regression, you get y equals ax plus b. The a is the rate of change of that regression with time. Now, here's the result. Now, this is a busy table, but of course the rows on the left are the various mills. The columns are the various factors. Now, the first 3 columns, S, N, and F, are the columns related to the sugar cane. The LM is the loss in milling. I refer to the sum, the loss in milling, which essentially is 1 minus A, the undetermined loss, and then B and C, and then at the end of the column on the right-hand side, you see the sum of the losses. In each case, this number that's represented here represents the rate of change of that parameter with time. So take an example of Amatikulu and sucrose, top left corner, 0.06 in the negative. In other words, the sucrose percent cane at Amatikulu is dropping by 0.06 units of sucrose per annum over the 10-year period. Now, go down the sucrose column and you'll see that there are a number of mills where the sucrose percent cane is getting less, the ones with negative numbers. And positive numbers mean the sucrose percent cane is improving. The industry average at the bottom on the left is 0.004 negative. So on average, the sucrose percent cane in the industry is deteriorating. If we look at the non-sucrose percent cane, you'll see in every single null area, with the exception of SASIAA down near the bottom of the column, every single null area, the non-sucrose percent cane is getting bigger. It's getting worse. It's positive. Now, at the same time, the milling performance, the ability of the mill to extract the sugar from the mixed juice, and therefore the propensity to leave sugar in the molasses, the B factor, is increasing. Every single null area, the B factor is getting worse. Now, if you put all of these together, some of the losses, which are represented there in the right-hand column, is getting worse in every single null area in the industry. I want you to pay particular importance to the bottom right corner there, 0.05. I'm going to look at it just now again. If you look at Nuudsburg, look across the line, there should be good reason for the growers at Nuudsburg to sit down and discuss the changes in the sucrose, non-sucrose and fiber. And good reason for the miller at Nuudsburg to sit down and look at the changes in the undetermined losses, and the losses to molasses and to bagasse. Industry average is looking very sad. It's all going the wrong way. As I said, please pay attention to the 0.05 at the end. A lot of those linear regressions that I fitted are not the best fit using a simple straight line. In fact, in some cases, an exponential curve would have been a better fit. So, to show the point, I did some regression, and I'm showing here 3 null areas. I did some regression over the last 5 years, and compared that to the regression over the 10-year period. Now, I'm going to draw your attention to the bottom right-hand corner again. You can actually go and look at the text of the paper to see all of the individual factors. The bottom right-hand corner tells you the sum of the losses over the last 5 years of the period was 0.1. I asked you to pay attention to that number in the previous slide with 0.05. So the losses are increasing at twice the rate over the last 5 years that they did over the 10-year period. So let me show you this in a little bit more detail now. This is a bar chart of the sum of the losses for the industry. The legend at the bottom will tell you that the undetermined losses is the bottom part of each bar chart. The losses to molasses is the greater portion of the bar chart, and the losses to fiber are the top portion. Now, the units of this are tons of lost sugar per 100 tons of cane. Now, in all milling operations, there are losses. So let's not worry about what the actual loss is, but let's look how these losses are changing with time. When I do a regression over this cluster of bar charts here over the 10-year period, it's a fairly good fitting straight line. So let me show you. On the left is A, which is the regression of those bar charts over the 10-year period. You can see that there's a fairly neat fit with R squared being 0.8. And the regression coefficient I was telling you about just now, 0.05. Look on the right-hand side, and you'll see that even neater fit with R squared being 0.9, and the regression coefficient being 0.0997. I guess you can easily approximate that to 0.1. 2 times the regression coefficient over the 10-year period. So what do we conclude with this? All 6 parameters, the 3 milling and the 3 growing parameters, are getting worse with time. The velocity of the deterioration is accelerating. I showed you the 10-year graph and I showed you the last 5-year graph. The velocity is accelerating. The RV formula appears to be not current enough. The way the RV formula is used, we take the 3-year moving average for the factors B, C, and M. And if they are deteriorating with time, and you're using the numbers for the past 3 years, you're using numbers that are going to overstate the quantum of RV that is available in the cane. The fact that A is set to 1 and R, which I haven't discussed, is actually outside of the RV formula, also leads to overstating of the RV. Now, our industry needs to sit down and investigate on a mill-by-mill basis. Why is the RV formula not fulfilling its task of creating an incentive for people to improve their performance? Why is the cane that's being delivered reducing in sucrose percent cane, rising in non-sucrose percent cane, and rising in fiber percent cane? Why are all mills' undetermined losses getting worse? Why are all mills' extraction of boiling house recovery getting worse? Why are all mills losing more and more sugar to fiber? Why? And I think this is a good challenge to both this agronomist grouping and to the millers to sit down and find out why these factors are deteriorating. Thanks for this paper. I must acknowledge the Cane Growers Association for supporting my attendance at a conference in Argentina last year and for supporting this work. I must thank Sheila Naidu at SASIAA with the CTS for collating the data set for me. And in particular, I must thank my son Lau Murray for his invaluable support. Thank you very much.